Oh my god, I've got too much work lately. And you, what are you doing, Mr. Engineer?
Well, I'm working on a project of a photovoltaic panels.
Well, that sounds great. I'm very interested. I've got some of those home, but I don't really know how they work.
How can I explain? I remember an episode of the Big Bang Theory that can help you. You understand the photovoltaic panels at the microscopic scales.
Oh, let's check it out.
Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids. Math, science, history, unraveling the mystery that all started with a Big Bang.
I'll tell you about what... What's going on?
My electricity bill. I don't get it. It's higher and higher from month to month.
Don't worry, Penny. I heard the owner wanted to invest in photovoltaic panels.
Photo what panels?
It's...
Photovoltaic panels, that's easy. You transform light energy from the sun into
electricity, so...
I'm sure you don't even know how a photovoltaic cell works.
Oh, come on, Sheldon. I have a master's degree in engineering. I know how PV cell works. So we can approach a PV cell with this circuit. Here you have the photons coming from the sun. They have an energy, they create an electron-hole pair that makes current. In a perfect circuit, you have this resistance near to zero, this one close to infinity. So you can get this EV curve with the short circuit current and the open circuit voltage. So in this perfect case, you can have this kind of PV curve, but in real life that's impossible because those resistances are not perfect. In fact, when this resistance decreases, the open circuit voltage decreases too, and you can have the EV curve given by the blue function. And when this resistance increases, the short circuit current decreases too, and the EV curve is given by the yellow function. And as you know, the efficiency depends of these two values.
Could you please make it more complicated?
Yes, we can!
Holy shit.
It's important to understand that a PV cell is composed of two zones. A P region, which has a lack of electrons, so it's positively charged, and an N region, which has an excess of electrons, so it's negatively charged.
Yeah, that's right. When we put both of those materials together, the excess of electrons from N regions goes to P regions, and the excess of holes from P regions goes to N regions until reaching a balance called neutral zone. When we apply a voltage in the direct polarization, the potential in the neutral zone is getting powerless, which allows the electrons passage. An opposite voltage occurs a reaching of the neutral zone, so the electrons can't go by. In conclusion, the p-n junctions acts like a diode, which allows the passage of electrons only in one direction.
But Raj, can you remind me the movement of the electrons when the cell is lit?
When a photon enters a semiconductor, and only if its energy is greater than the gap band, it can transfer its energy to an electron and bring it from valence band to conduction band, leaving a hole. We talk about electron-hole pair.
Interesting. But I can bring more details. When the cell is lit, for example, by the sun, it creates some electron-hole pairs in the p-n region. Because of the diode, the electron in the conduction band can pass in only one direction. So the hole are going to be filled by another electron taken from another atom. And it creates electric current.
But you can't really explain how things work, you're just assuming facts and you don't know the origin. If you really want to explain the existence of a band structure in a solid, you have to use quantum physics. If we followed simply rules given by classical mechanics like Howard always does, we wouldn't be able to explain the fact that a massive particle adopts only some levels of energy in a crystalline solid. Let me try to explain to the inferior minds that you are some of the beautiful world of quantum physics.
Sheldon, may I ask you a question?
Considering your schooling, Penny, I think you should.
How long are you gonna talk about that?
As long as necessary. So, the Schrödinger's equation. This equation can describe the quantum state of a particle by giving its wave function and energy level. In fact, we will have to use probability, which is not really what Oompa Loompas of science are used to do.
Hey.
To explain the existence of a band structure in a solid, we have to solve Schrödinger's equation for a potential that can model the structure of the solid. In particular, in a crystalline solid, the atoms are arranged in an ordered pattern in all three dimensions. The resolution of Schrödinger's equation in a crystalline solid shows that particles can adopt only some levels of energy that are in certain bands. The band theory is explained.
It was funny. Do you think photovoltaic has a bright future ahead of it?
Of course, to fulfill the world's energy needs while preserving the environment, photovoltaic is a must.
Are photovoltaic panels all the same?
No, photovoltaics are classified in generation. The first are based on a single p-n junction, the second consists of thin film cells, and the third tend to increase the efficiency of the photovoltaic panels with multi-junction p-n and concentrator photovoltaic system.
I've heard of organic photovoltaic cells too.
That's right, but this technology is relatively new.